Okay, this is part 3, looking at measures of central tendency, and just wanted to, I did get cut off in that last video, but just wanted to make sure that we were all good there. Just the whole idea of that was that the median is more resistant than the mean, because one change that was relatively drastic, going from everything in the 7-ish range down to 1.7 did not really affect, it didn't affect the median at all, actually. So the median is more resistant to change in small and large values than the mean. So now we have this one looking at dealer's profit. So we got the following data represents the profit in dollars of a new car dealer for random samples. So now you're seeing that word sample. So we're going to be, if we look for a mean, we're going to be using X bar of 40 cells. So you got all of the data here, and we want to determine the shape of the distribution of the new car profit by drawing a frequency histogram, and then find the mean and the median. So I'm going to jump over here. I'm just going to hide this, and actually here's all of my profits. And so then with all my data, I'm going to go into graph and a histogram, and I'll go by profits. I'm going to compute, and I'm first just going to see what StatCrunch gives me, see if I need to adjust any of the classes. But I like those class ranges. We're going by 500s. It gives me a good idea of the shape. So it looks like the shape here is going to be skewed to the right. So if you're skewed to the right, you might think to yourself, how is the mean going to compare to the median? Okay. And you can actually see that by going to Options, Edit, and then we can put in markers for the mean and the median. So again, think, is the mean going to be greater than the median, or is it going to be less? Okay. So now ask yourself where you're right. So the mean is 1,392.825. The median is 1,177.5. So since this is skewed right, you would expect the mean to get tugged towards these extreme values. So the mean is greater than that median. So in this case, when you're skewed, you want to you would want to actually use the, so coming back to our question here, when you're skewed, you would want to use the median in place of the mean, because the mean is affected by these extreme values. So it would be the best to describe the profits. So and again, that mean X bar was 1,392.83, and the median was 1,177.50. All right, so again, there's that picture right there for you. Now the last thing we're going to do is we're going to look at an idea of where we've got a missing score or a missing grade. So we've got a professor has recorded exam grades for 20 students in his class, but one of the grades is no longer readable, so something happened to it. But he knows that the mean score was 82. So the first part, what he knows is if he takes the first test score plus the second test score plus the third plus on up to, well, I'll just call it, I'm going to call it R for the unreadable score. So he knows if he adds all of those up and then divides by 20, that is going to be the mean of 82. So that's just the formula to find your mean. Again, you add up all of the different values, so all 20 divided by however many there are, which is 20 in this case, and that equals our mean. So then the next thing says the mean of the 19 readable scores is 84. So when he takes the first plus the second plus the third plus on up till he gets the, it's not the 20th, the 19th, and he divides that by 19. So when he finds the average or the mean of the 19 scores, that's 84. And we want to know, with this information, what is this unreadable score? Now, if you look at it, okay, the mean of the 19 is bigger than the mean of the 20. So that tells us that the score, that unreadable score, has got to be less than, in this case, it's got to be less than 84, because that mean's coming down. So we may think, okay, how are we going to do this? Well, remember right here, this is x1 plus x2 plus x3 all the way up to, plus x19, and then plus that unreadable score r. So we can actually solve for that right here. So in this bottom equation, what I'm going to do is I'm going to times both sides by 19. Okay, and when I times it by 19, what this tells me is x1 plus x2 plus x3 plus on up to x19 is 84 times 19, or let's see, I get 1,596. So now what I can do is I can replace this piece right here with 1,596. So create myself a little divide here. So then I would have 1,596 is the sum of those first scores, those first 19, plus the unreadable, divided by 20. That equals the average of 82. And now it's just some basic algebra to solve for the unreadable score. So times both sides by 20, times by 20. So then I have 1596 plus r equals, and if I do 82 times 20, that's 1640. So then I would minus 1596, and I would get r is equal to 44. And that is your unreadable score. So the process is a little bit meticulous, but even without knowing any information about the other scores individually, we're still able to find that mean. So that wraps us up for the measures of central tendency. Appreciate your time, and let me know if you have any questions.